Hello everyone, welcome back. Today we will see 10 more important questions in Java multithreading for the interview perspective. We will see the answers in detail as well. So if you are new to the channel, please go ahead and subscribe and don't forget to like and share. So without any further delay, let's start with the first question. What is the concept of thread pool? A thread pool is a collection of pre-initialized worker threads that can be used to execute tasks and put back to the pool when the task is completed. So to create thread pools, we have executor framework in Java depending on the requirement. Like we have fixed thread pools and scheduled thread pools as well. Next is what is callable interface. So as of now, we already know that there are two ways to create thread. One is using thread class by extending the thread class, and second one is using the runnable interface. So by implementing the runnable interface, we can create threads. But after Java 1.5, one new interface was added, which is callable. So using callable interface as well, we can create threads. So callable is almost similar to runnable. It is used to encapsulate tasks that are needed to be executed by another thread. It is a new one that was introduced as part of the concurrency package in Java 1.5. It addresses the limitations of runnable interface. So runnable interface cannot return anything, and also exception handling is not possible. But in case of callable, it can return some value. It can also throw some checked exception as well. Next question is how to make sure that new thread starts the execution only after the previous thread has completed. So suppose there are two threads and we want that the second thread should start its execution only once the first thread has completed its execution. So the most basic way is to use the join method. Join method is available in Java multithreading, which will what it will do, it will wait for the thread to complete its execution before continuing with that. So if we see on the left hand side, this is how ideally we should create and start the thread. But if we do in this way, we don't know when these two threads will execute because the execution depends on the scheduler. And it is possible that thread 2 can start before thread T1 as well. So how we can make sure that first T1 starts, and once T1 execution is complete, then T2 should start. So on the right hand side, you can see first we will start T1.start, and after that we will use T1.join. So what this specific line will do, it will block the execution at this point in the main thread, and it will not go to T2.start until the T1 thread is completed. Other than this, we can make use of cyclic barrier and countdown latch as well to control the execution of threads. Next question is what is deadlock? So deadlock is a situation where multiple threads are blocked forever. It generally occurs when multiple threads hold lock on different resources and are also waiting for other resources to complete their task. So let's look at this image and see how the deadlock has occurred. So here you can see thread 1 has already acquired lock on object 1 or resource 1, and at the same time thread 2 has also acquired a lock on object 2 or resource 2. But to make further progress, thread 1 requires a lock on object 2 as well. So it will try to acquire the lock on object, but as thread 2 already have the lock on object 2, so thread 1 will be blocked. So it will be blocked indefinitely until thread 2 releases this lock. And at the same time, if we see thread 2 is trying to get the lock on object 1, which is already locked by thread 1. So here you can see these two thread will go into deadlock because both of them are blocking and no one is releasing the lock on already acquired objects. So this situation is known as deadlock. So once you explain the deadlock, the follow-up question will be how deadlock can be avoided. The first one is lock and unlock order. So we should be acquiring the locks in sequence and releasing them in the reverse sequence. The second one is using thread.join method. So we can get deadlock if two threads are waiting for each other to finish indefinitely using thread join. Then our threads has to wait for another thread to finish. Then it's always best to use thread.join method with a maximum timeout as well, that you want to wait for the thread to finish. The last one is we should be avoiding nested locks. So the deadlock mainly happens when we give locks to multiple threads. So avoid giving locks to multiple threads if we already have given those locks to the other threads. Next question is what is volatile? So volatile is actually a keyword. that is used to address the visibility issue in the multithreading. The visibility issue is nothing but, like, suppose there are two threads which are manipulating one variable, and both have read the variable value at one point, but one thread has already updated its value, but that value is not returned to the main memory as of now. That is currently available in that thread's cache. So the other thread will not be aware about the updates which has happened to those values. So to avoid such scenarios or such issues, we can use volatile variables. So this keyword cannot be used with classes and methods, but only variables. It is simply used to achieve the thread safety. If we mark any variable as volatile, then all the threads will read its value directly from the main memory rather than from CPU cache, so that each thread can get the updated value of variable. Next question is, what is synchronization? Synchronization helps us to limit the access of critical resources in the multi-threaded environment. This makes sure that a resource will only be used by one thread at a time, and when other threads try to access the same resource which is locked, it will be blocked until the previous thread releases the lock on that resource. It can be achieved using synchronized method and synchronized block. So after this question itself, the follow-up question could be, which one is better, synchronized block or synchronized method? So synchronized method will lock the complete method, and no other thread will be able to enter that method until the lock is released or the previous thread has completed the execution of whole method. On the other hand, synchronized this block will only lock a set of critical code block and keeping the other code lines in the method open for other threads to execute. So in that way, multiple threads can enter into a method, but there will be a set of critical code lines which we have added in the synchronized block. Those will have only a single thread access. Due to this, actually, the synchronized block perform better than methods, and we should prefer using synchronized block over synchronized method. Next is, what is thread starvation? So the thread starvation is a situation where a thread will not get regular access to the shared resources and therefore is unable to make any progress. This is because other threads have high priority and occupy the resources for too long. Thread starvation usually happens with the low priority threads that do not get CPU for its execution to make any progress, because the higher priority threads will keep on getting the CPU. The next question is, can we start a thread more than once? This is a tricky question. So the answer to that question is no. It is not possible to start a single thread twice. Thread only runs once, and if we try to run it the second time, suppose there is a thread T1 and we have already executed T1.start, and if we try to do it again after that line T1.start, then it will raise a runtime exception, which is illegal thread state exception. So that's it for this video. We will come up with more advanced questions in multi-threading in our upcoming video. So if you like the video, please do like, share and subscribe. Thanks for watching. See you next time.